Hello everyone, welcome to Reactify Labs. Today we will be doing a Leetcode problem called median of two sorted arrays. So, before that, let's talk about median. So, for calculating a median, we have two cases. Okay, first is if the size of array is odd, second is if the size of array is even. Okay, so let's say if we have two arrays of size m and n, okay, and actually no, let's not go there first. Let's say if we have a array of size n, then if n is odd, then the answer is I think n by 2, n by 2, yeah, middle element. And if it is even, then it's n by 2 plus n by 2 plus 1 by 2. I think something like this. I forgot the exact formula. Let me explain using an example. So, if it's this 1, 2, 3, 4, 5, since the number of elements are odd, this is the middle element, right? But if we have 1, 2, 3, 4, 5, 6, then the median is this, sum of this by 2. So it's 3 plus 4 by 2, which is 3.5. Okay. So we can say that if the size of array is odd, then the median will be the middle element, which is there in the array. But if the size of array is even, then the median will be the sum of two middle elements, and it may or may not be present in the array. Okay. Why two middle elements? Because you know something is a middle element if we know something is a middle element. Let's say this element is a middle element if you have equal number of elements on the left and right side of it. But in case of even, you have two middle elements so that you have equal number of two elements so that you have equal number of elements on the left and right side of them. That's why we say two middle elements, because if you see, if we take only 3, we have 2 elements here and 3 elements here. For 4, we have 2 elements here and 3 elements here. So that's why we say we have 2 middle elements, 3 and 4. So combining them, we have 2 elements to the right of them, 2 elements to the left of them. Okay. Cool. So let's test what we understood. So if we have array like this 1, 4, 5, 7, 9, 11, 13, then the middle element is 7 because odd number of elements. And if we have, let's say, 14 as well, then the middle element is 9 plus 7 by 2, which is 8, and 8 is not present here. Okay. So it's like this, it may or may not be present. Okay. Okay, so I think I've explained this. Now let's move to the problem statement. Okay, so the problem statement says we have two arrays and both arrays are sorted in non-decreasing order. The question can be, why did I say it's non-decreasing order and why didn't I say it's increasing order? Because if we have, let's say this 1, 3, 4, 5, 9, this is increasing order. Okay. This is also non-decreasing order. This is increasing order, this is also non-decreasing order. But if we say we have 1, 3, 3, 4, 5, 9, then this is only non-decreasing order because it is not decreasing. But also it is not always increasing because here it is not increasing. Okay. Increasing order is this. But if it is like this, flat, and then this is non-decreasing order. Okay. Similarly, decreasing order is this. Okay. But if it goes like this, then this is called non-increasing order. Okay. So enough of technical jargons. Let's actually move to the problem statement with examples. Okay. So you have two arrays, okay, two sorted arrays, array 1, 1, 3, 5, 7, 10, okay, and you have another array 2, which is 2, 4, 8, 11, 15, 16, okay. So now if you see, you can say that the easiest solution would be to create a new array, okay, and just sort and merge the two arrays above as we do in merge sort. What do we do in merge sort? We find all the arrays, we divide and conquer, and in the end we just merge, right? We compare and merge. So if we compare and merge, we find that it's 1, 2, 3, 4, 5, 7, 8, 10, 11, 15, 16. What is the size of this? 5, 4, 9 to 11. So the size is 11. So the middle element is this, right? So that it has 5 elements to the left of it, 5 elements to the right of it. Great. So this is our answer here. But we do not want to do that. And actually we are not expected to do that as well, because we are not in 5th standard. We are engineers. So we are supposed to use our knowledge, whatever we have studied. Have we studied binary search? Yes, we did. So we have to use them. Okay. Because if we use this, then our space complexity becomes order of m plus n. Okay. Let's say it has size n, it has size m, it becomes m plus n. Our time complexity becomes again order of m plus n, because we have to compare all the elements. Okay. We have to optimize it. We have to do the space complexity order of 1, and time complexity can be log of m plus n, okay, or log m plus log n, whatever it is, whatever is the worst case. Why I said worst case is m plus n? Because if m is m and n is 0, then it's log m plus n, which is log m. So yep, you got the point. Okay. How can we do that? So we know that we cannot create a new array. Okay. But what I also know that what we can do is we can first find out what should be the actual mid. It means we should know m plus n is odd or even. If it is odd, then we know that we have to find only one mid. Okay, one mid. But if it is even, we have to find two mids, right? So we know that. We know this as well. Okay, let's use this. So in this case, we know that our m plus n is odd, correct? Because m plus n is 11. Because it is 11. Okay, what can we do now? So first we calculate a new variable, actual mid, which is called actual mid. The mid would be this mid is if the arrays were sorted and merged. Okay, then this mid would be m plus n plus 1 by 2. Okay, so you may ask here, why m plus n plus 1 by 2? Okay, because here if you see, our m is 6, our n is 5. Okay. So now if we do m plus n plus 1 by 2, then what we get is 6 plus 5 plus 1 by 2, which is 6, correct? No problem here. But let's say if we had n also 6, m6, n6, then it would be m plus n plus 1 would still be this would still be 6 plus 6 plus 1 by 2, which is 6. Correct? It means if we have 11 elements or if we have 12 elements, in both the cases, if you see, we have to get the sixth element here, and here also we have to get the sixth and seventh element, right? So m plus n plus 1 by 2 gives us the actual middle, where we should know where the calculation is going to be, okay? Because if it was not m plus n plus 1, if it was only m plus n by 2, then 6 plus 5 by 2 would be 5, okay? But if the 11 elements are there in the array, the middle element is not the fifth element. Yes, it is the fifth index, but it is not the fifth element, right? It is the sixth element. So that's why, to accommodate that, we need m plus n plus 1 by 2, okay? So I hope that is clear. So we have m plus n plus 1 by 2. Now what we do is we calculate the mid 1, okay? So mid 1 is the middle element in array 1, which is 0 plus n by 2, okay? 0 plus n by 2, which is, so basically this is the index. So the index should be 2, because n is 5. 5 plus 0 by 2 is 2, correct? Now we calculate another mid 2. We have two options. We can do 0 plus m by 2. But if we do that, then we have dependency on both the arrays to find the actual mid of them, both of them, and to coordinate them as well with the combined array. Okay. To be clear, we do not need the combined array. I am only using combined array as a mental mapping, that so that it's easier to understand that, okay, there is a combined array. We are not actually going to make it. Okay. So if we do this, we have dependency. We have dependency of this calculation in both array 1 and array 2. So instead, what we are going to do is, we are going to leverage these two to find mid 2. So the mid 2 is actually mid minus mid 1. Okay. This is our mid 2, because we do not want an extra dependency. Okay. Now you see this. If we find the mid of this, okay, it is index 2. Our actual mid is, let's write somewhere. Mid 1 is 2, mid is 6, right? Okay. So if we find mid 2, it is 6 minus 2, which is 4. 0, 1, 2, 3, 4. So this is our mid 2. Okay. So if you see, if we sort it, since we have sorted it here, we have got this element and we have got this element. Are they close? No. Is there any other way to know that if they are close or not? If there is any way of getting our answer through these? No, because we don't know. They are very, very heavily distributed, right? So what we are going to do is, we are going to leverage this mid to find the left and right. So let's say this. So when we have our mid, okay, we find that, okay, let's name some variables called left 1, left 2, right 1 and right 2. Left 1 and right 1 will belong to this. Left 2 and right 2 will belong to this. Okay. So left 1 would be the element which is to the immediate left of mid. Okay. So let's name it left 1, and this mid becomes right 1. Okay. This mid becomes right 1, and this becomes left 2, this becomes right 2. Okay. Now you calculate. So we know that left 1 is 3, right 1 is 5, left 2 is 11, right 2 is 15. Okay. So if we have to get our answer, okay, if we have to get our answer, what we are doing is we are calculating the left and right. So in any case, okay, if the array is sorted, if the array is, oops, sorry, what happened? Yeah, if the array is sorted, any left, okay, any left should be less than or equal to its right. Correct? Any left. We are using the left and right for easier understanding, so that we know that, okay, this element is left, this element is right. And in any case, a left will always be smaller than equal to right. If it is not, if this is not the case, then we know that we have to do something else as well. Okay? This is the main catch. A left will always be smaller than equal to its right. Not its right, any right. Okay? Since we know that in any array, since you see this array is sorted, this array is sorted. So when we calculate left and right, we are calculating using mid. It means if right is mid, left is mid minus 1. So it means that here that category, that rule, that condition is already satisfied. Yes, left 2 is always less than equal to right 2. Right? Left 1 is always less than equal to right 1. But what we need to compare is, if left 1 is less than equal to right 2, is left 1 less than equal to right 2? Is left 1 less than equal to right 2? Yes, it is. But is left 2 less than equal to right 1? No, it is not. So the left 2 is not at correct position. Okay? If left 2 is not at its correct position, we should do something. Right? We know that left 2 is not at its correct position. Okay? Remember this. Left 2 is not at the correct position. So what we need to do now is, we should shift. Okay? We should shift left 2. And to shift left 2, what do we need? If you see, we got our mid as 6. Okay? We got our mid 1 as 2, right? And mid 2 depends on mid and mid 1. Okay? Mid is fixed. Why is mid fixed? Because the entire size of the array will always remain constant. We cannot, even if we do some tweaks on the like, what can you do? You can do m plus n by 2, m plus n plus 1 by 2. This will always remain the same. So mid is fixed. This size is not going to change. Okay? You have to have this, because the overall mid, the overall size of the array will always remain same. What you need to find out is, where should your partition be in the array 1 and array 2? So for that, we know that the only variable we have is mid 1. Okay? Since the only variable we have is mid 1, so should we push mid 1 to its left or right? We know that we have to push mid 2 to left, right? Because left 2 is larger than right 1. It means left 2 is larger than right 1. It means left 2 should go towards left. If left 2 should go towards its left, okay? If left 2 should go towards its left, it means this difference, which was now 4, which was earlier 4, it should reduce to 2 or 1 or 3, something, right? It should reduce. And if this should reduce, it means mid 1 should increase. If mid 1 should increase, it means mid 1 should go up from 2, either 3, 4, 5, something, right? So that's why what we are going to do is, we are going to increase mid 1. Okay, if you did not understand, replay the video. Okay, replay the video and you will understand. There's a little bit of understanding that, okay, if mid 1 is 2, mid is fixed, and we have to decrease mid 2, then the only way is to increase mid 1, because mid 2 is dependent on mid and mid 1, and mid cannot be changed. Mid is always fixed. Okay. So how do we increase mid 1? Mid 1, if you see, is dependent on 0 and n. It means mid 1 is dependent on start and end of it. Okay. So as we do in binary search, we will shift our start to mid plus 1. Okay, so it means the start will be shifted to mid plus 1. So the earlier mid was 2, now the start is 3. Okay, end is as usual 5 because n is 5, and so the new mid one becomes how much? 3 plus 5 by 2, which is 4. Correct. So the mid one becomes 4, and hence mid 2 becomes 6 minus 4, which is 2. Correct. Now let's do the same thing again. Let's change the color. Okay, I hope yellow is visible. So now we have mid 1 as 4. Okay, so mid 1 is now 4. 0 1 2 3 4. Mid 1 is now 4. Okay, and mid 2 is now 2. 2 is 0 1 2. Mid 2 is 2. So now our L1 is this, R1 is this, L2 is this, R2 is this. Correct. Again we do the same calculation. Okay, so our L1 is 7, L2 is 4, R1 is 10, R2 is 8. Okay, now compare. Is left 1 less than equal to right 2? Yes. Is left 2 less than equal to right 1? Yes. So our condition is satisfied. Now since our condition is satisfied, we know that if we arrange these in sorted order, all the lefts are like this, all the rights are like this. The condition is satisfied. So now what we need to do is we need to find first if the entire size, if the net size of the array, this combined array, which we did not create but it's in our mind, okay, is this odd or even? Since we know that it's odd, so the answer will be the max of these two. Okay, the answer will be the max of these two. You may ask why? Because we have our mid, we have calculated our mid, okay, and we are making sure that the mid is taken care of by the number. Okay, if you see, we took its position as in actual position, 6th position, not the index in array. Index in array is 5th. So that's why our answer will be taken, or it will be coming from left. Okay, but if it was from an even sized array, if it was from an even sized array, then if you see here, we have our new combined array, and in this case, if you see, if we take the max of these two, we get 7. If we take the min of these two, we get 8, which is what happens in an even sized array. Let's say if it was 17, okay, just for the time being, assume that it's 17, then you see 5 elements here, 5 elements here. So if we take the max from left and min from right, we get our 2 mid elements in case of even sized array. You try that in your learning or in your revision. You will find that yes, this is what happens. So that's why if it is odd, our answer will be max of left 1 and max of left 1 and left 2. Okay, but if it is even, our answer will be max of left 1 comma left 2 plus min of right 1 comma right 2, right, as we discussed, and divided by 2. Okay, this is our answer. So again, if you see here, what happened was left 2 was greater than right, that's why we moved it here. In other case, if let's say this were greater than this, it means that there is some element here, there would have been some element here, mid, which would have been greater than this, which is the right element. In that case, what we would have done is, we would have, instead of start equals to mid minus 1, we would have done instead of start equal to mid plus 1, we would have done start equal to mid minus 1. Why? Think about it. I have explained this in the previous case, the same logic will apply here. Okay, I am not going to spoon feed you. I have already done the spoon feeding. It's up to you now to chew. Okay, so yes, this is our answer. The only condition that you need to check is this. If you understood this, if you understood how to find this, you have your solution, because after that there is nothing you need to do. The only thing that you need to do is calculate the left and right, and understand as well. Don't memorize the solution. Understand why left and right calculations are done like this, why left and right comparisons are done like this. Okay, why left one is not compared with right one, and why is it compared with right two? Because left one is already compared with right one when we did the sorting. Okay, because we didn't do the sorting. The sorting was already done for us. Okay, anyway, enough of me. I'll stop the video here, and yep, if you have any doubts, please let me know in comments. And I hope you liked the video. I hope you understood the solution. And as usual, thank you for watching. Please remember to like, share and subscribe. I will see you in the next one, hopefully very soon.